title. You ready? Sammy, you ready? G, got the book out ready to go? Should already have them. Matt, got the book out? Why don't you two desk it at the moment? You could turn around and use that desk to write on, and then the other one to use your laptop.
Oh my gosh, he's a legend.
Double desker. Alright. So here's your first thing we're doing. Using a rule to write out the numbers in a pattern. That's one thing that's what we're doing. So it's not really a title as a statement of what we're doing.
Hey, look.
Does that count?
Yes.
No, I'm looking at Kieran. And Logan, yeah, he's still on his mouse. Is that 5 for Logan? That's just touched it 4 times.
Oh my god,
Put your laptops to one side, that's a warning. Put your laptops down to one side so you're not touching them. Alright, your book should be out, you should be writing, making notes. Everyone else has done it. Come on. Okay, using a rule to write out the numbers in a pattern. So, we're just recapping, refreshing. So, if I said to you, Tn equals, Rocco, could you give me a kind of a rule that would give me a linear pattern? 5n subtract 3. Now, if I said to you, describe the pattern that rule will create, what could you tell me without telling me the numbers? That's telling me a process. Describe the pattern. Is there anything specific you know about the pattern? Okay, so that's what I was looking for. We know we add 5 every time. How do we know we add 5 every time? Holden, how do we know? Sorry, I've caught you while you're drinking. No, that's all right. I'm just saying, I was going to ask you, and then you were in the middle of drinking when I asked you. Not your fault. Do you know the answer? No. Jordan. Say again.
He's saying the first term would be 2.
What question did I ask?
I don't know that it goes up by 5.
How do you know it goes up by 5? Yeah.
Oh.
So the answer 2 is, doesn't go with it. Ryan.
Because it says that you give 5 by the term, which means it's up by 5, you're going to multiply it by 5.
Okay, so remember the n is which term we're on, yeah? That's actually a tricky thing for a lot of people to understand. It is a common thing people find difficult. So the n is which term. So if n is 1, we're looking for the first term. If n is 2, we're looking for the second term, and so on. All right. Now we know from our physical patterns, don't we, that if we add 5 things every time, it will be 1 lot of 5, 2 lots of 5, 3 lots of 5. And if you have 1 lot of 5, then 2 lots of 5, how much have you added on? 5. So that's how I know that this number here tells me what the pattern goes up by. Because it's 1 lot of 5, 2 lot. And then this minus 3, that's the thing that happens the same every time. That's the core, right? So this is the pattern. Now we can use this rule to write the pattern. So for instance, I think G said if I said n is 1, then 2, then 3, then 4, then 5, I'm asking for the first 5 terms, yeah? Okay. So there's a couple of ways to do this. So we do 5 lots of n and then we subtract 3. So for the first term we have to do 1 lot of 5, read it that way around, then subtract 3. So that's, we have a block of 5, we subtract 3 from it and we get the answer 2. So the first term is 2. The second term is, well, let's do it the long way. We do 2 lots of 5. 2 lots of 5 written read that way, but written this way. Right? then subtract 3, because the core of it is you always have to subtract 3 from whatever 5 you have. So we've got then 10. Do you notice how the 5 becomes a 10?
Yeah.
There's an extra lot of 5. Then we still subtract the 3 and we get the answer 7. Okay? So we can say that the first term, look, is 2, but the second term is 7. So we can see it goes up by 5. So now we don't need, well, I'm going to do one more. So the third term, we have 3 lots of 5, which is the 15, and you'll see that 5, 10, 15, it's always going up by 5. And then the thing that doesn't change is the subtract 3. So the third term is 12. Okay, so third term, 12, so they match. Okay, and then you've done this over and over again. I think we're just practicing adding to notes. So then the fourth term is when n equals 4. So that gives me the fourth term. We can just do it a different way now. Instead of doing this, we then just add 5 to 12 and we get 17. And then we can just add 5 to 17 and get 22. Okay? So we've used 2 possible methods for that. Okay? Showing you what my page looks like at the moment. That's why I'm using it. So your page can look like that too.
It's done another thing where it goes 2, 7, 2, 7. Last time it was.
Yeah, that was the other thing, isn't it? Do you notice that's because it goes up in 5s, isn't it? Yeah. We've got that pattern. So instead of it always being 0, 5, 0, 5, if you start at a different number, it goes a pattern like that. Des? Well, if you have the same number, regardless what it is, it's a linear pattern. That's what makes it linear. You always add the same number. Yeah? So if I add 6 every time, it's a linear pattern. All right? Just so you know, if I multiply every time, so if I multiply by 2, multiply by 2, it's called a geometric pattern. All right? Another word for linear pattern is actually arithmetic, because arithmetic people say is like adding. So should we write just that sort of up here, just adding those? So we've got a linear pattern. Okay, this is what we're doing. We've got a linear pattern. It's also called, okay, an arithmetic. We would call it a sequence, an arithmetic sequence. You'll see called that. Can you all see what I'm writing? So those things, just so you know, are exactly the same thing. So linear and arithmetic. All right. Also, maybe this program's alright. I get lots more colours. It's a lot easier to do my highlighting.
I like it.
Good. Huh? And what's nice is when you print it out, all the colours look really cool.
Wait, you can print it come out.
Who what?
You can print it?
So you weren't listening either. You were drawing your pattern.
What?
And you say
You
we
can
the
print one
PDF.
for all of us, we don't have to do that.
Yes, I could. But the reason why I don't do that is because while you are writing notes, you're actually thinking about what you're doing. Yeah? And it's prompting you to ask questions, which you will love, which is good. So, yes, that's why I don't really like just giving you all the notes. But what I do is some of you will struggle to make the notes in the time, so it will be available to you. Oh, laptop, what's with the laptop? Megan, do you want to put it there? I didn't tell you to turn it round. Can't resist. Right, so I think we're all done this part. Just one thing is, guys, TN 5n minus 3, just to check, I've done the first 5 terms, the 5th term being 22, and we can do it by this method or the add 5. Look, it's always just add 5. And I showed you, I'm going to do some more highlighting, why not? We've got 1 lot of 5, 2 lots of 5, 3 lots of 5. So you can see how that bit matches here, yeah? All right. That's great. Huh? So what if I said to you, I want the 201st term. Now what I'm therefore asking is, imagine that I've not written 5 numbers out, I've written all 200 out, and then I want the next one. But that's a bit unrealistic, isn't it? If I say I want the 201st number, I'm not going to ask you to write out all 201 numbers and just add 5 every time. That, by the way, is perfectly okay to get the correct answer, if you have all the time in the world. We don't. Alright? So you can add 5 200 times. Don't want to do that. So what we have to do is, Emma?
You have to multiply 201 by 3 and then subtract
By 3?
by 5.
So remember, the pattern is, for every term, we have that many lots of 5. So we start with 201 must be 201 lots of 5. You see it from here? So we're using 5n minus 3. So it must be 201 lots of 5, and then subtract 3, and we get the answer, Kieran? Tristan, you show us?
1002.
1002. So if I were to write in the list, blah, 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 I would then get to the 201st term is 1002. Alright? But I've skipped out a load. How do we feel about that? Yeah? It's repeating a lot, but it's good to repeat. This is a super important one, because we're doing linear at the moment. And I say I'm doing linear with M2s, and I'm also doing linear with M3s. It gets repeated a lot, right? So it's really important to be, because then when you get to M4s, we're now doing quadratic patterns and exponential sequences and reciprocal patterns and rational. Yeah. So you have to be good with the linear stuff. All right, should we move on to the next thing? The next thing is, so you're going to write this down. Can I tell if a number is in the pattern or not? Yeah? So can I tell if a number is in the pattern or not, without having to write out the whole pattern? All right? How you feeling about Holden, all right? Yeah, all good? Jake, what's up? I will say yes, but remember, there are people in here that are relying on your explanation, so be as simple and clear as you can be.
Simple.
Go for it, G.
Okay, you do it right.
Okay, shall I write a rule? So shall I say is, give me a number, 412 in the pattern of Tn equals, well, should we do 5n subtract 3? Okay, makes sense. Let's do the same thing again, yeah? Makes sense. Does make sense. Why not? Let's carry on. G's in the middle. Go on, G. Right, you're skipping a step. There's something I should say first. Right? Is 412 in the pattern of Tn? What you're doing is you're going straight to the how, right? right? Not, you're skipping the what. So what is the what I've got to do, Kieran? What is the what?
I would explain it is by look at this pattern above. It goes 2, 7, 2, 7.
Yeah, but do you remember, we want to try and avoid, although it's a feasible thing to do, we could say it ends in a 2. So that gives us a clue that it very could be, but sometimes, yeah, we do know, yeah, I fully agree with you, right? Because we know it's going up in 5s, it's going to be end in a 2 or a 7, but that's only because I've already written some of the pattern down, right? And I know it goes up in 2, 7, 2. What if I hadn't written any of that pattern? Would you need to write out the first 5 terms first? Well, then I wouldn't have seen that it goes up in 2, 7, 2, 7, you see?
Which is 2, 5 minus 2, which is 2. Then 5 plus 2 equals 7. So 2 and 7 is a repeating number.
But do you know it's repeating just from 2 numbers? So everything you're saying is definitely along the right sort of lines, but we have to be careful that we don't make assumptions that could be wrong, right? So what you're saying is perfect. Like we could figure out a pattern, does this number form, but there is another way that I would like to extend you onto. Daisy, you've had your hand up a lot. So remember, I want the what do we need to do, not the how at the moment.
Okay, so what you need to do is you need to, can you see the pattern that's there? And what you're going to do is you're going to add the 3.
No, you're telling me the how again. It's difficult, isn't it? I'm challenging here. Right.
I have a question. If we were doing this, like, would the term of 412 be 83?
That's not a question.
Yeah.
That's
I mean,
well, it is a question, but you're ready.
But if it is, that means that it's in it.
Okay, actually, let's take what you've just said. He did approach the what, which is, if it is, we should be able to figure out which term it is, yeah? So that's what we're actually asking. I'm going to use a different colour now. What value of n would give me 412? Okay, so we're looking in our table of, so we know the first term, like Kieran was saying, is 2. I know the second term is 7, and so on. But what I'm looking for is now, which value of n gives me 412? That's what I'm trying to do. Yeah? What value of n would give me 412? Now comes the how. Do you have a question or do you want to tell me something?
I want to see if I could. Oh, just never mind. I was gonna. I thought I tried.
Go for it.
I did. I was trying to find the placement, the term.
Yeah.
I don't know. I think I'm probably wrong. But is it the 82nd term?
Well, you think 82nd. Ryan thinks 83rd. Did you both do a kind of trial and error methods? Well, I want a kind of, let's do it again with our mathematical. G, try again.
So we would do 412 plus 3, and then we do the
No, you haven't done something yet. You're confusing people. What do I have to write first? The pattern is given by 5n minus 3. What we're asking is, does that equal 412? That's the question, okay? What you've been doing, guys, is you've been telling me the hows. You've gone straight to this without telling me to write that. Now, this is the important step. If you can't remember to write that, you will struggle. All right? So can you all write that in your, let me pause. Right. Go back to recurrent. So we're going to do 5n subtract 3. So I think we've done this before. In this one, I can actually split it vertically. Here's my equals sign. All right? And I'm going to put in 5n's. Now, what is quite good about this one is up here, I can actually put in an n if that's what I'm going to use. All right? And I can click labels. Why is it not doing it? It should.
Mine ran out.
Label. Actually, click labels. Yeah.
I ran out.
Okay, so I've got 5 n's. And 5 n's subtract 3. So that means I need -3. Okay? So that's that side. What's up, Logan? But I'm showing you now. No one knows how to use this one. So laptop, start. Yeah? That's exactly what I'm doing. I am showing you how to use something new. All right? All right, so that has to equal what? Oof, blimey. Positive 412. So I think what you can do is you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? This one, I think this is the 412, thanks to G. I tell you what, so you're seeing the limitations. So let's just go back to the problem. All right? Should we change it slightly? Yeah, see, now you get it. Let's change. But once we've learned the process, we can go back to this one. Let's change this. Instead of 412,
41.
let's just do 41. Okay?
Wait, so we have to erase all of them.
Erase all the twos.
Just take the 2 off. Yeah? Let's do that.
So
What value of n would give me 41? That's actually, for me, quite good. I quite like this.
we still have to do
You still have to do 41. But you get the idea. Let's take the time. It would be quite nice.
How do you split it down the middle?
So, yeah, click split and then click vertical. Alden, what's up? Right, okay guys, now this is the important bit. Alright, this is the important bit. This is where we learn what we're actually doing, and you'll be able to expand that knowledge to not need the algebra tiles, but it is here if you need it. Alright? So that's what I'm saying. If having done this you say, yeah, I don't need algebra tiles, right? That's absolutely fine. Okay? Now here's what we have to do. Are you all with me at the moment? You've got your, whichever program you're using, you've got the 5 n's subtract 3 is equal to, so this bar represents the equals bar, and on this side is 41 units. So this and this should have the same value. Alright? Alright? This is worth the same as this. So imagine it was money. Alright? Each n would be worth like a bag of money. We don't know how much is in it. And then so someone gives you 5 bags of money, but then takes $3 away. And they say, right, in those bags, you have, but with $3 taken out, you have, Sammy, you with me? You have $41. That's what they're telling you. And they say, you can keep all that money if you can tell me how much is in each bag. Right? So we have to do a bit of kind of sleuthing, and we have to say, right, well, if the 5 bags but subtract 3 is worth 41, then like you're saying, if we haven't subtracted the 3, we would have 3 more, yeah? Now, in the algebra tiles, what that means is this. What we have to do, if we want to know what it is, all right, before I subtract these 3, obviously, I have to add the 3 back on. All right? Make sense? Because then it ends up being 0, yeah? Now, the reason why I do it like this is because that then shows me that if I add 3 ones on this side, what must I do to the other side? Have to add 3 on this side as well.
You just copy your thing.
Yeah, I've just run out as well. But yeah, I think you should be able to, you can still copy.
Cool. I wrote this X down the one thing.
Right. Reese, don't worry about changing all the colour. If you've just deleted everything, just get on and reset it up. All right. First off, sorry, Max.
What we could do to make it so they all add up, we could drag the other ones and put them on top of the smaller.
Okay, so Logan, are you with me at this point? Because obviously you've got, if you're struggling, you've got to be fully on now, yeah? Are you all right at the moment? Which bit? Oh, I can't. Have you set up the equation to start with?
Oh my god. It doesn't even
No, guys, come on. We're all helping each other here. All right. What we do now, I'll come and help you in a bit. What we do now, guys, is because we added the 3, we did that because I want to get rid of the minus ones. Because what you do is if you put the ones over the minus ones, they cancel each other out and make zeros. Okay? But what's then good is because you added the 3 this side and added the 3, we can then add these 3 to those. Okay. Now, that makes that the 5 ends, the 5 bags of money, if you haven't subtracted the 3, must equal 44. Yeah? Make sense? All right, now here's what's useful. We've now got to share that 44 between the 5 bags of money to figure out how it goes. All right? Now, if you struggle with division, this is quite useful. So what I then do, it might take you a bit of time. I'm going to take one at a time and share it out. So put it next to the n, yeah? And then I could do another line. So go for it. I'm going to... Now, you will see on my... Can everyone look at my screen now? No touching laptopy. Right? No touch the laptop. Put your laptop down. Do it quick. I've got 2 minutes. Get right down, put it away. Turn around. Face this way. Right, because you're going through the process, right? So hopefully you have got to the stage where you've split them up, you've divided. Now, if you're still doing that, that's fine. You'll get quicker at it. You don't need that. Just rock over. Come back. Come on. Quick, quick, quick. All right. Guys, so what I need from you to understand is, to answer this question, is 5n subtract 3 equal to 41? What's the n value? So what we did was we added the 3, and this is why we say, you right, hold it? Yeah. We add the 3. Now that makes it so that 5n's is equal to 44. Right, now what I then did was I divided the 44 by the 5n's. But here's the question for you. What do I notice? Emma?
The last is missing one.
Good. So this top n is worth 1, 2, 3, 4, 5, 6, 7, 8, 9. So is this one, so is this one, so is this one. But for it to be a proper number in the pattern, they all have to be the same number. And because this one turns out to be 8, that means the 44 does not divide by 5. So what does that mean? It's not a number in the pattern because it doesn't work. And as I will just jump back to what Kieran said, because we knew it was a number that should have ended in a 2 or a 7, we kind of knew that 41 wasn't going to work anyway, didn't we? Alright? Okay, so I know the bell is gone. What do you have next? Right, so because we take this out, guys, let's just finish these notes. Got your books? No laptops? Right, important. 5n minus 3, does it equal 41?
No.
Well, okay, if we add the 3, 5n should equal 44. If we divide by 5, n equals, well, can you do that on your calculator for me? 8.8 is it? Okay, now we said yesterday, we then ask, so you're putting laptops away instead of writing notes, that's not going to help you next time. Does this make sense?
No.
The answer is no. N must be a whole number. Okay, so what value of n will give? Is 41 in the sequence? No, it's not, because we don't have a whole number. Did you write that, Zabby? Sure. If I can check them. See everyone else still writing, that sort of thing. All right.